All right, in this video, we're going to be exploring a type of physics called fluids and how it helps planes to fly. So this whole study of something called fluids. Fluids are things that don't have a fixed shape, and when you push on it, it can kind of move around. So this is a little bead of water right here, and just so you can imagine that this bead of water doesn't really have a fixed shape. Like, it's probably going to flow right through these little slats, and if you press on it, it'll move around. Jello, like pudding. Pudding is a fluid. Air is a fluid also. We kind of like imagine air as a bunch of little tiny air particles flowing around. And then also things like water and other liquids are tiny little particles flowing around. There's this cool YouTube video right here I'll show you. It's all these marbles that are kind of flowing through this sorting object. And what was really striking when I saw this for the first time is that it's kind of like the little tiny particles of air or water or any liquid or gas that flow through an object. So that's kind of what I wanted to show you there. So when we talk about air, that's a gas, or water, that's a liquid. They're both fluids. They could be moved around. They don't have a fixed shape. Like solids have fixed shapes that they don't really change from unless you were to cut it or something like that. All right, so let's talk a little bit about fluid. One thing about fluid is that it flows. So there's different types of flow. The type of flow that we really like when we're talking about aircraft is laminar flow. So laminar flow is when fluids flow smoothly and at a constant velocity. So they're all kind of going at the same velocity. They're not speeding up or slowing down. And they're just kind of rolling along at a nice, easy, sort of smooth path. What we don't like when we talk about aircraft is turbulent flow. So you can imagine turbulent flow is when you have fluid that is moving in kind of irregular, sort of curvy action, and we have a bunch of these little whirlpools that sort of pop up. If you've ever used an oar when you're like in a rowboat, you'll see that you don't really create laminar flow of water. You make little whirlpools. So you're actually creating turbulent flow of the water when you use like an oar in a rowboat. So the little whirlpools and the kind of curvy action of the flow with turbulent flow causes our plane to kind of be jacked around a little bit, and it doesn't cause a very nice flight. So let's talk about this a little bit more. Oh, this is a really nice picture that shows the difference between turbulent flow and laminar flow. So at the very bottom, you can see that we have kind of smooth kind of action of the smoke. The smoke is actually acting like a fluid. And up here towards the top, we have the little whirlpools, little eddies right here, kind of all over the place. You can see it really nicely right here. So the flow is all mixed up and random and at different speeds, very different than at the very bottom where we have laminar flow. So the key takeaway here is that we like laminar flow, because if you have laminar flow, you're going to create consistent lift. This is what that means. So here's kind of just a little picture of an airplane wing from the side, and you can see the laminar flow going around the wing. That's really nice because that means that our lift force that we talked about before, which is an upward force, the lift will stay the same value, right? That lift is opposing the force of gravity or weight. Remember we talked about weight? And weight is always going to stay the same. And when you have the same weight and the same lift, then your plane won't go up and down. Instead, it'll kind of stay on a similar path, and your passengers won't be jerked around up and down. We wouldn't want that to happen. Now, if you've ever flown in a plane, sometimes there's turbulence when the plane kind of bounces around a little bit. That happens when you have turbulent flow around the wings. If you have little eddies or little whirlpools around the wings, you can get turbulent flow. And what happens is that the plane jiggers up and down like this, right? It goes up and down, and the more turbulent flow, the more raising and dropping of the plane you get. Because, guys, the gravity is going to stay the same. But if you have different amounts of lift, like sometimes it's a lot, sometimes it's a little, that means the plane is going to follow this kind of up and down sort of action. We don't like that. As long as your plane has laminar flow around the wings, then you won't get turbulence. So turbulence is not our friend when we talk about aircraft. A lot of times you get turbulence and dirty air when the plane is flying through a storm, because in a storm, a lot of the air is moving up and down, and it's not as still as it would be if there wasn't a storm. Let's talk about another thing here in terms of lift and laminar and turbulent flow. So another way to get a lot of turbulent flow is if you have, if your plane is angled way up. So up here, this is kind of like the angle at which the wing is sort of kind of at. You can see it's sort of a low angle of attack, they call it. So that angle is pretty low. Now, if we come down here, this would maybe be more like if you were taking off. You have a higher angle of attack. It's a little bit, maybe a medium angle of attack. The problem is if your angle of attack gets super steep like this one, what ends up happening is that you get a bunch of turbulent flow. You can kind of see this over the top of the aircraft wing. And then what could happen is you could reduce your lift. You could stall. Stalling is when your plane is kind of at an excessive angle and you're getting a lot of turbulent flow. And what happens is that your plane will just drop out of the air because all the lift will go away. The lift force will go away. That is bad time. So you don't want to ever have your airplane being or your aircraft being, going straight up in the air like this. You'll get a bunch of turbulent flow, which will screw up your lift, and you won't. You'll stall out and you'll just fall. Gravity will pull you down because you don't have enough lift. Let's just talk real quickly here about lift and how lift is created. To do that, we need to talk about kind of what a fluid is and what pressure is. So remember, we were talking about fluid. You can imagine these containers having air inside of them, little air molecules bouncing around. Over here, we have low pressure in this first container. Okay, so we have the kind of like you can think of pressure as little molecules bouncing off the walls as they're bouncing off the edges of the container. And if you don't have a ton of those collisions and they're not very violent, you'll have low pressure. But as you kind of like push the container downward, the container lid downward, you have a lot more of these collisions happening over time. And so you'll have higher pressure. So the tendency is for fluids to want to be at low pressure. So the fluids don't really like being at high pressure. So instead, we're kind of the fluids will flow, or the air will flow from high pressure to low pressure. All right, because the fluids really like having low pressure. They don't like having all these collisions occurring. So that's the big thing here. Fluid always goes from higher pressure to lower pressure. If you don't believe me, look at a balloon, right? A balloon has very high pressure on the inside. And if you pop the balloon, air will actually try to escape out of the balloon to get to lower pressure. So it's just, the air molecules want to go to a point where there's not a ton of collisions. So that's why air comes out of a balloon. It goes from high to low pressure. There it is. It's just written down here. Fluids always flow from high to low pressure. So here's our last slide, and let's talk about high to low pressure with an airplane. There's this idea, it's called Bernoulli's principle. But what people have found is that with fluids, if they're faster, if they move faster, we have lower pressure. And if we're going slower, if air or any fluid is going slower, we have a higher pressure. So what that means is that air will go from kind of slower to faster conditions. All right, so that's kind of what we have here. All right, so we're looking at an airplane wing. An airplane wing is pictured right over here. So here's the wing right here. And we can imagine that the plane is moving in this direction. So that's the movement of the aircraft. Okay, it's kind of moving like that. Okay, in this direction over here. All right, so what we have is we have air that's flowing over the wing. And without going into all of the fluids mechanics behind it, basically what ends up happening is if you have a wing shaped like this, where the top of the wing's a little bit curved and the bottom of the wing is kind of flat, what you have is you have higher or faster airflow on top. So the air is going to be moving faster along the top of the wing than the bottom of the wing. All right, so the bottom of the wing is going to have slower airflow. And what we just said before is that slower airflow leads to higher pressure. So what we have is we have high pressure on the bottom, and low pressure on top. So when you have high pressure on the bottom and low pressure on top, you end up having this force, and that force is called lift. All right, so the air tries to get from high pressure to low pressure, and while that's happening, what happens is that we experience that as lift force. So that is how a wing provides or creates lift. If you have faster air on top as compared to the bottom, then you'll have higher pressure on the bottom and lower pressure on top. And because of that, you create lift. So that's how lift is created. It's just a difference in pressure from the bottom of the air, the bottom of the wing to the top of the wing. So I'm going to demonstrate lift with this piece of paper. So what I'm going to do is I'm going to blow over the top of the piece of paper so that there is higher velocity fluid over the top of the paper as compared to the bottom of the paper where I'm not going to blow. And as I'm blowing the top of the paper, we're going to create lower pressure on top of the paper because the fluid will be going faster. And there'll be high pressure on the bottom of the paper because there'll be slower, the fluid will be going slower. Actually, it'll be zero. There'll be no airflow on the bottom. So I'm going to create this difference in pressure. Low pressure on top because of the high velocity coming out of my mouth. And then high pressure on the bottom where there will be no airflow. And then you'll see that I'll create lift and the paper should go up like this. Let's try it out.